Hello there, good morning. So for today's lecture, we will be discussing mechanics of tooth movement. As for the learning outcomes, you should be in a position to outline the different types of tooth movement and types of force used in orthodontics. Coming to the introduction of mechanics of tooth movement. So what you need to know here is what is biomechanics? Biomechanics is the reaction of dental and facial structures to orthodontic forces. So it's the reaction of the dental and facial structure to orthodontic forces. So it was William Prophet who put forth this explanation. And why do we need to study biomechanics? So to understand how the different forces work, different kinds of movement of teeth, and also to understand the clinical and histological responses of the dental apparatus, to also enable accurate treatment planning, wherein you can use biomechanics to predict tissue responses, and also it will enable you to design your appliances better. To understand biomechanics, you need to be familiar with these terminologies. One is center of mass, the next one is center of resistance, the other one is center of rotation, and you also need to understand what is a moment and what is a couple. Center of mass. So what is it? If you want to balance any object freely in space, you have to find the point at which the mass of the body is concentrated. So that is known as center of mass. So it is equivalent to the center of gravity in an environment where the object is free. So if you want to balance an object freely in space, you have to understand where the object's mass is concentrated. So that will give you the center of mass. Center of resistance. What is center of resistance? So this is the point through which the resultant of the forces acting upon a body would produce a translatory or bodily movement. So when a force is applied to a body at this particular point, that is at center of resistance, the body moves in the opposite direction, or it translates in the opposite direction of the applied force. So that is center of resistance. So basically it's the point at which, if a force is applied, will result in a translatory movement. Center of resistance depends on a number of factors. It depends on the length of the root. It depends on the number of roots a tooth has, and it also depends on the level of alveolar bone support. So for a single rooted teeth with normal alveolar bone, it is located at 1/4 to 1/3 of the distance from the CJ to the root apex. So the yellow dot here represents the center of resistance. However, for a multi-rooted tooth, it lies 1 to 2 millimeters apical to the furcation area. Here are a few examples wherein you can see how the position of center of resistance changes when the root length is different and also when the alveolar bone height is different. So the image in the center shows the center of resistance to be apically located if the tooth has a longer root or if it has reduced bone height. However, the image on the right will show you that the center of resistance is more coronally placed because the tooth has a shorter root, also has higher alveolar bone height. So basically, it is easy to understand where the position of the center of resistance of the tooth is located based on how long the root of the tooth is, and also how high the alveolar bone support of a particular tooth is. So why do we need to know where the center of resistance of a tooth is located? So if you want to know in what direction a tooth is going to translate, you have to understand where the center of resistance of a tooth is located. So if the center of resistance is located at the furcation area and the force application is um, in the direction as shown in the arrow, the tooth will translate in that particular direction. So the same happens when force or the direction of force is changed, the tooth will translate in that particular direction. And again, if the force or the direction of force applied is changed, the tooth is going to translate into the opposite direction. So knowing center of resistance, you can understand where the tooth is going to translate or in which direction the tooth will translate. Here we will see what happens if the force applied is above or below the area of the center of resistance of a tooth. So if the force of application is at the crown area, then the crown tips in the same direction. However, there can be a minimum amount of root movement in the opposite direction. If the same force were to be applied in the root area, what happens? So the root moves or rotates in the opposite direction with minimum or no movement of the crown. So this is known as tipping. Center of rotation. So what is center of rotation? So it is the point around which the tooth seems to rotate when force is applied. So when you apply a force to a tooth, the tooth seems to rotate in a particular direction. But this rotation occurs around a point. This point is known as center of rotation. So if you consider the long axis of the tooth in its initial and final position, both of these lines will intersect at a point, and that is known as the center of rotation. Here are a few examples of how the tooth will rotate when forces are applied at different levels or at different areas. So if the force is applied at the crown of the tooth, then the center of rotation is apical to center of resistance. If force of application is at the middle one-third of the tooth, then the center of rotation is at the apex of the root. If the force is at the apex of the root, then the center of rotation is located at the incisal edges. However, if the force application is in line with center of resistance, then center of rotation is located in an infinite plane. So the next concept we will be learning is a moment. So what is a moment? The measure of the tendency to rotate or the rotational tendency of a force is what is known as moment. So if the force were not applied through the center of resistance of the tooth but through any other point on the tooth rotates in addition to moving in the direction of the applied force. So you already understand this. Since the tooth did not receive a force at the level of its center of resistance, there is a tendency for the tooth to rotate. This tendency is known as moment. So how do you measure moment of force? So you can use a formula wherein you multiply magnitude of force by the perpendicular distance from point of force application to the center of resistance. So when you multiply these two, it will give you the moment of force, which is expressed in gram millimeter. So the next concept is a couple. So here it is nothing but a system of two parallel forces of equal magnitude acting in opposite directions and separated by a distance. So this couple creates pure rotation around the center of resistance. We will go into the details a little later. So now what you need to understand here is it's uh, nothing but two parallel forces of equal magnitude acting in opposite directions separated by a distance. That is what is known as a couple. So we shall now see what are the different types of tooth movement you come across in orthodontics. So there is tipping, which can be controlled and uncontrolled. There can be translation or bodily movement of a tooth. There can be intrusion and extrusion of the tooth. There can be rotation. There can be torquing and also uprighting. I know it's a little bit confusing. However, I'll try to uh, keep it as simple as possible so that you can get uh, the concept and grasp the idea behind it. Now we shall see what tipping is. So tipping is the simplest form of orthodontic movement when a single force is applied against the crown of a tooth and the tooth rotates around its center of resistance. So the image on the right um, will help you understand how the tooth moves when a force is applied at the bracket and the tooth is rotating around its center of resistance. So this kind of movement usually requires very low magnitude force and also it results in uh, the crown movement being more than the root movement. Also, what you need to understand in such kind of tipping movement is there are areas of resistance and there are areas of compression. So when the force is applied at the crown region, so the center of resistance makes the tooth to rotate. So when this rotation occurs, um, the PDL is compressed near the root apex on the same side of force application. However, um, there is area of compression of the PDL fibers at the alveolar bone region on the opposite side. So we've already understood this pressure and tension concept in our biology of tooth movement. So you'll have to remember those and connect it with how tipping causes areas of pressure and also areas of tension. So tipping can be controlled and uncontrolled. So here we will see what is controlled tipping. So when there is force application on the crown, so the crown moves in one direction, but the root position remains the same or it gets minimally displaced. So the force makes the tooth to rotate around its center of rotation. However, there is movement of the crown in one direction, but the root position remains the same or it gets minimally displaced. This is what is known as control tipping. So what is uncontrolled tipping? So when the force application occurs, the crown moves in one direction, whereas the root moves in the opposite direction. And the tooth rotates around its center of rotation. So the movement of the crown is in one direction and the movement of the root is in the opposite direction. So that is what is known as controlled tipping. Okay, what is translation or bodily movement? So here, when there is a force applied at the same level of center of resistance of a tooth, the tooth will bodily move or translate in an opposite direction of the point of force application. So the root apex and the crown both move in the same direction and the same amount. So these are obtained by forces which act along parallel lines and are distributed over the entire alveolar bone surface. So that is what causes the tooth to move bodily. So however, you can see there will be an area of compression as you can see in the loading diagram. So when the force is applied, so the whole periodontal region or the alveolar bone uh, around the tooth root is compressed, causing the tooth to move bodily. So how do we achieve this bodily movement using fixed appliances? So you know where do we place brackets on the teeth. So from this position, do you think it's possible for us to bodily move teeth? Uh, yes, it is. The reason being, uh, when a force is applied on the tooth, uh, the original force causes the tooth to rotate, which is called the moment. We've already learned about it. However, to counter this, there is another force or a counter moment, which is actually in the angulation of the bracket slot, which is known as the torque. So by using this torque, we can actually produce a counter movement to the original force. So when this happens, these two moments cancel out each other, and there is a pure force which causes the tooth to translate. So that is how we can actually use fixed appliances to move teeth and affect different movement of teeth. So here you can see it more clearer. So the moment is cancelled by a counter movement. Okay, so the tendency of the tooth to rotate is cancelled by the counter movement. So this cancellation causes pure translation or bodily movement of the tooth. Okay, the next tooth movement we will learn about is extrusion. So what is extrusion? It is the bodily displacement of a tooth along its long axis in an occlusal direction. Okay, movement or bodily displacement of a tooth in an occlusal direction is known as extrusion. So extrusion movements ideally do not produce any areas of compression within the periodontal ligament. However, there will be areas of tension because it is stretching the periodontal apparatus. So what is intrusion? Intrusion is the opposite of extrusion. It is the bodily displacement of a tooth along its long axis in an apical direction. So primarily the anterior teeth are intruded. So light forces are required, and the force is concentrated in small area at the tooth apex. So you can see the loading diagram. So when there is an intrusive force, uh, the force concentration is at the apex of the tooth. What is torquing? Torquing is nothing but the movement which is opposite of tipping. This is tipping, okay, wherein the crown movement is more than the root movement. Torquing is when you see more root movement than crown movement, and the center of rotation is at the incisal edges of teeth. The next type of tooth movement is uprighting. Uprighting is the mesiodistal movement of root. So during orthodontic treatment, crowns of teeth tip in a mesiodistal direction with the roots tipped in opposite direction. So we have to tip the roots back to get a parallel orientation, and this is what is known as uprighting of teeth. So the next kind of movement is rotation. Rotation is nothing but a labial or lingual movement of a tooth along its long axis. So when two forces of equal magnitude are acting in opposite directions, it produces a couple and it creates a movement which causes the tooth to rotate. So how do you rotate a tooth, or how is rotation produced, or how is it possible? So you have to remember couple and counter couple. Okay, so when there are two equal and opposite forces, they are usually cancelled out. Okay, and this will prevent it from moving bodily. So when this happens, the tooth will rotate around its long axis. So just look at the image. There is an arrow going to the right, there is an arrow going to the left. Okay, those are the red arrows. So these are, one is creating a couple, the other one is creating a counter couple. So when these two are cancelling out each other, the tooth cannot move bodily. Instead, the tooth will rotate as there is still a force being applied to the tooth. So this particular force will create a rotation of the tooth around its long axis. So when a tooth is rotating, what happens is there will be two uh, sides of pressure and also two sides of tension. So that is what you have to understand, and then you have to give it enough time for the tooth to rotate or derotate. So we're coming to the last leg of today's lecture. So that is orthodontic force duration. So how are they classified? And they're classified by the rate of decay as continuous, interrupted, and intermittent. So what is a continuous orthodontic force? So these are forces which are maintained between the activation of orthodontic appliances. So if you see the image on the right, you can see that there is a rate of decay. However, following activation, the forces are maintained, following which again there is decay, again reactivation, and so on. So the force is constantly maintained. So if the force is light, there will be frontal resorption. So I hope you remember what is frontal resorption. So frontal resorption is a favorable one. So there will be a smooth progression of tooth movement. However, if the force is high, so it will result in an undermining resorption and also excessive areas or zones of hyalinization, and so the tooth movement is delayed. So if you apply light continuous force, there is frontal resorption and the teeth can move smoothly. Okay, so this happens when we use fixed appliances. What are interrupted forces? So these are forces which will decline to zero between activation. So you can see it on the image. As the decay occurs, it reaches zero, and then again you have to reactivate. Then there is a period of decay followed by a lag period. So that is what is known as interrupted force duration. So here the force will drop to zero at one point and it will remain in that position until the next activation. So any kind of movement occurring during this period will be halted, and only upon reactivation will that movement again continue to take place. So the third kind is known as intermittent force. Here the force level declines abruptly to zero intermittently. So especially when using removable orthodontic appliances um, with an expansion screw. So till the expansion or till the screw is being activated, the force is being translated. Once the screw is stopped, or the screw is no longer being activated, the forces will decline, okay, or it will stop abruptly. So that is what is known as intermittent force. So with that, we've come to the last slide of today's presentation. So today you have understood what are the different kinds of tooth movement and also the various terminologies used in orthodontic biomechanics. So I wanted to keep the lecture short and brief so as to not overwhelm you with a lot of information. So we shall wind up today's lecture. Thank you so much for listening.